Hello everyone. Today we're going to walk through the answer for this week's brain teaser on the protein and structure module. We gave you the two accession numbers, GU 306149 and GU 306147. Here is the brain teaser. We want you to do a BLAST analysis of these two accession numbers. And we want you to look at the mismatches between the two transcripts and then also the corresponding protein sequences. Do a BLAST analysis for the two protein sequences and then compare the number of mismatches between the transcripts and between the protein sequences, and that will underscore a biological concept. So let's go back to the nucleotide database, retrieve the two accession numbers, and notice that these are both transcript variant 1. The GU 306149 accession number is in the Spanish links, and then the GU 306147 accession number is from the cat. So related species but not identical. We can retrieve one of the accession numbers for the specific database record, then run BLAST. We want to check the box that is aligning two or more sequences. Notice that the accession number is entered on the top box. I'm going to copy this, put it into the bottom box, and then just change the accession number to that one for the cat. I'm going to click the BLAST button so that we get the analysis. I'm going to click the BLAST button so that we get the analysis. And I'm also going to open the formatting options. I like to change the pairwise to pairwise with dots for identities, and also put on the CDS feature box. You need to click the blue reformat button. And then as I scroll down the result, you'll see that we have a nice solid red line for the full length. The two sequences are 1562 bases long for the links and 1560 bases long for the cat. As we scroll down to the alignment, we see that the two sequences are 99% identical, and even in the first set of 60 bases that are aligned, we have one nucleotide difference. As we scroll down, you can see additional differences. So we have 3 nucleotide differences so far. Scrolling down some more, this is difference number 4, number 5, number 6, number 7, number 8. And there is a difference here at the 3' end. For the purpose of this brain teaser, we are going to ignore the 3' end. We are only going to focus on these 8 differences that have been identified so far. If we scroll back up to the top, we notice that the first nucleotide difference, there's no difference in the amino acid. There's a H for histidine, and that is still the same amino acid even though there is a nucleotide difference. However, for the second nucleotide difference, there is a difference in amino acid Q versus H, and so on. You can look at this through all of the rest of the differences. Now, we also wanted you to do a blast of the corresponding protein accessions. So I am going to go back to the links record, open up the corresponding protein record, which is ADU 04378, and I'm going to do a blast analysis with that record as well. I'm going to go back to my initial retrieval of the CAT and links records. I'm going to open up the CAT record. And this is so that I can get the protein accession number for the corresponding CAT transcript variant record. So here I have my BLAST P, or my protein BLAST, almost set up. I'm going to click the Align to Sequences box again, and now I'm going to paste in the CAT protein accession record. Again, click BLAST. And one of the reasons to do the protein BLAST is that the algorithm will identify those amino acids that are in the same family, and so even though there might be a different amino acid, it's still in the same family of amino acids, so there might not be as big of a difference. Again, we have the links protein, 503 amino acids. The CAT is 506 amino acids long. And then when we look at the alignment, we can see that it's 99% identical. And the difference, the first difference is here, that Q versus H that we saw before. There is another difference here. And this is why I wanted you to do the BLAST P analysis as well. Notice that there was a gap in the alignment between the Q and the H. Here there's a plus, so that is saying to me that the I versus V amino acid is in the same family. I believe this is an isoleucine and a valine, so there's not as much of a difference between an I and a V as between a Q and an H. And we can see the other differences. Here's another difference. I believe that there are 3 differences in the protein sequence, but we had 8 differences in the nucleotide sequence. Once again, going to the assignment, let us open the table that we mentioned and the article. And the biological principle that this brain teaser is wanting you to reinforce in your learning is the fact that there are some amino acids that are coded for by more than one triplet codon. You can see that leucine actually has 6 triplet codons that will encode for leucine. Tryptophan only has a single triplet that will code for it, and this is called the degenerate genetic code, where you have more than one triplet codon that will code for the same amino acid. So again, going back to the assignment, we retrieved both nucleotide accession numbers. There were 8 differences between the 2 transcripts. We looked at the 2 protein records. There were only 3 mismatches in the protein sequences, and that principle is illustrating the degenerate genetic code, so that even though you have a difference in the nucleotide sequence, you may or may not have a difference in the encoded protein. There may be a difference in the amino acid, or there might not be. That difference might be important because it completely changes the protein sequence, but yet it is because of the degenerate code that not all changes of the nucleotide sequence result in a different amino acid.